Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Friends, still you are going to report me this. Let me just brief you what is the ideal duration and what is the agenda of this session. So friends, the ideal duration of this session is going to be approximately 1 hour. And the agenda or the objective of this session is that today we are going to discuss some of the important concepts with the help of some questions as far as your subject power system is concerned for your upcoming examination, that is BARC and HAL. So all the candidates who have attempted the GATE 2022 examination and now they are going to appear in the BARC or the HAL examination, this session is going to be extremely important for you if you belong to electrical engineering, because power system, as usual, you understand, is one of the most important core subject and it finds a significant weightage in both the examinations. Before I proceed further, let me just tell you that in comparison to BARC and HAL, if you compare, the level of questions is going to be little moderate to difficult size in case of BARC examination, whereas in case of HAL examination, the questions are going to be easy to moderate because of the level of the examination and its requirement. It is important to discuss it. When we are going to combine these two exam session, for example BARC and HAL, definitely I will be taking more and more focus on the conceptual clarity for the subject, because definitely the questions exactly can't be repeated, but concepts are going to be repeated in one way or the other way. So all the candidates who are joining me live, once again just quickly confirm your presence in the comment section and do not forget to like, share and subscribe the session. Just quickly like the session, share it with your friends and colleagues, and do not forget to subscribe BYJU'S Exam Prep English YouTube channel. So with all your support, shall we start the session, everybody? Shivajit, BS, Sudhir, everybody tell me in the comment section. Shall we start? Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience. Completed MTech from ITBHU in 2010. I have written a couple of books also, and my areas of expertise are power system, electrical machines, electromagnetic field theory, material science and engineering ethics. Yes, everyone. Let us start with the first question. I am starting with the basics of transmission line, and today we will be trying to cover. Yes, BS Sudhir, Guru Hoja Shuru. Thank you so much. You remember that. I will be starting from transmission line because this is one of the most basic chapter from where you start your subject power system, and we'll try to see how much we can complete today. We have two sessions. Today is the first session, lecture 1 is today, and we'll be having another session, okay, that you can see in the schedule. He's asking a 220 kilovolt, 20 kilometer long 3-phase transmission line has the following ABCD constants. ABCD parameters are given. He's asking the charging current per phase is. Now please try to understand, whether he is writing per phase or not, charging current you will always find in terms of per phase. Charging current you will always find in per phase. So whether it is mentioned find the charging current per phase or simply it is written find the charging current, don't confuse. You simply find the charging current in terms of per phase. Now let us try to understand what is charging current. If you see the most simple equivalent circuit of your transmission line, then you can understand what is charging current. Suppose this is the sending end voltage and the current, and this is going to be the receiving end voltage and current. This is the receiving end voltage and current. Now these are the transmission line parameters. Some current must be going through the shunt branch. The current which is going through the shunt branch, that is the current we are calling as charging current. So this current IC we are calling as charging current. Everybody just tell me in the comment section, are you clear with this? Now suppose you are asked to find the charging current. What is the best way to find the charging current? How you can very easily find the charging current? I will just give you a very logical way of finding the charging current, whatever case it may be. Whatever case it may be. Suppose you are representing your transmission line by using ABCD parameters. By using ABCD parameters, something like this. Now this is going to be the sending end voltage, sending end current. This is going to be the receiving end voltage, and this is going to be the receiving end current, and this is going to be the ABCD parameter. So how you can write the ABCD parameter equation in terms of the sending end voltage and current and receiving end voltage and current? You can write Vs is equal to AVR plus BIR. Similarly, you can write Is is equal to CVR plus DIR. Now the logic or the concept here is, whenever he is asking for the charging current and the question is framed in terms of the ABCD parameters, the only thing you do is you put the receiving end current 0. It means it is going to be the no load condition. When it is a no load condition, what is going to happen? If this receiving end current IR is going to be 0, it means whatever current is taken from the supply, that is nothing but the charging current. So now you can get a very simple definition of charging current. The current which is taken from the supply when there is no load connected at the receiving end or the load end, that current you are calling as charging current. Everybody just tell me in the comment section, are you able to follow this? So what we will do in this equation, we will put IR is equal to 0. The moment you put it, Is becomes IC, that is the charging current. This is going to be C VR, but please understand this VR is VR phase, because whenever you are using ABCD parameter to represent your transmission line, please understand you always use the per phase analysis. ABCD parameter is only applicable when you go for per phase analysis. Is it clear for everybody? So what you have to do, the value of C is given. The value of C is given. I am only talking about the magnitude, 10 to the power minus 4. And what is going to be the per phase receiving end voltage? The per phase receiving end voltage you can take from here. It is going to be 220 kilovolts divided by root 3, because this is the line voltage given. You must be knowing that transmission line rating will always be given in the line to line voltage. Whenever you are using the ABCD parameter or any other per phase analysis, it is better you change it into the per phase value. If you solve this, you must be getting somewhere around 6.3 ampere. So option A is going to be the correct answer. Is it clear, everybody? Just tell me in the comment section. Why the number of students are so less? Can you simply share it with your friends and colleagues in your social media groups so that more and more people are going to be benefited? It is not going to increase your competition. It is like just helping your friends. Let us see the next question. The next question talks about the sign convention of the source or the load, which is a very simple and very important concept for complex power in power system. He is saying there is a single phase load which is supplied by a single phase voltage source. So let us try to understand what is happening here. The situation is there is a single phase load which is supplied by a single phase source. He is saying if the current flowing from load to source, he is giving you this value of the current. Load to source is 10 angle minus 160 degree. The current is flowing from load to source. That is the value is given. Now he is giving you the voltage also, the voltage of this terminal, and the voltage at the load terminal is 100 angle 60 degree. This is the current. This is the current, and the voltage is given as 100 angle 60 degree. Now he is asking what is going to be the nature of real and reactive power. You must be knowing what is the sign convention for source and load. Everybody just tell me in the comment section, are you comfortable? Yes, Chuvajit, you are right. Everybody just tell me in the comment section, are you comfortable with the sign convention for the source and load? Otherwise I can tell you, because you may get a question on this. In your examination, you may get a question on this. Now see what is happening. If I have to write for the load, if I have to write the power for the load, what I need? I need in the polar form voltage multiplied by the complex conjugate of the current. Voltage multiplied by the complex conjugate of the current. But please understand, when you write this equation and you follow the sign convention for the load, this current is the current taken by the load from the supply. This is the current taken by the load from the supply. It means actually you have to write this current. Actually you have to write this current, IL. Are you getting this? Are you getting this? So what I will do, I will first try to find this IL current, that is the current taken by the load from the source. How I can find it? Let us use the phasor diagram analysis. He is saying, suppose this is the reference, this is the fixed reference. He is saying the voltage is 100 angle 60 degree. So the voltage is going to be somewhere like this. Voltage is going to be 100 angle 60 degree. Now this current I, which is from load to source, is given as 10 angle minus 160 degree. So 10 angle minus 160 degree is going to be somewhere here. This is going to be I, that is 10 angle minus 160 degree. And this angle is going to be 160 degree. And this angle is obviously 60 degree. Now if you see from this circuit, very easily you can understand that this IL is going to be simply minus I. You just reverse the direction. Sound buff. Shubhajit is saying discuss once. Okay, I will discuss. I just got your comment. I just got your comment. So just give me 2 minutes. Now the sound is okay. There may be some friction. Okay, I will just tell you, please wait, please wait. What is the sign convention for the source? What is the sign convention for the source? Sign convention for the source says that if you write the complex power as VI complex conjugate, which you can write as P plus JQ. Are you getting this? If you are writing the voltage and current in the polar form, then you write the complex power as voltage multiplied by complex conjugate of the current. And if you are finding the values of real and reactive power, if P or Q or P and Q, any one of them or both of them, if they are coming positive, if they are coming with a positive value, what does it mean? Because it is a source. So what is the basic nature of source? The basic nature of source is to supply power, whether it is real power or reactive power. So it means it supply this much real or reactive power to the load. If you are getting a positive value of real or reactive or both the real or reactive power. If any of this or both of these, they are coming with the negative value. They are coming with a negative value. What does it mean? Now the basic nature of source is to supply power, whether it is real power or reactive power. But after the analysis, after writing this equation for the power for the source, if you are getting P or Q as the negative value, if you are getting a negative sign, what does it mean? It means instead of supplying the power, the source is absorbing the power. That is the sign convention for the source. So if you are getting P or Q, any one of them or both of them with a negative sign, it means it absorbs power. It may be real or reactive power. Let us try to understand the sign convention for the load. What is the sign convention for the load? What is the sign convention for load? Again, if P or Q, they are coming with a positive sign, what does it mean? What is the basic nature of load? The basic nature of load is to absorb power. So with a positive value, it means it absorbs power. If you are getting a negative value, what does it mean? if you are getting a negative value, what does it mean? It means instead of absorbing the power, the load is supplying the power, whether it is real power or reactive power. This is what we understood with respect to the sign convention for the source and load. This is extremely important. Please try to understand. Any number of questions you will see, they are asked in various examination year on year. So this is what we are doing here. We are writing the complex power for the load, and with the help of the sign we are getting for the real and reactive power, whether it is a positive sign or negative sign, you can comment about the nature of the power, real or reactive power. Are you getting this? But you must understand, when you are writing this power, complex power, with this notation, then this current IL is the current which is taken by the load from the source. So with the help of phasor diagram, what I am going to do, I am using this relation, IL is minus I. So what you do, just reverse this I. So it will be coming something like this. This will be IL, which is nothing but minus I. And this will be, the magnitude is going to remain as same, that is 10. Now what is going to be this angle with respect to the fixed reference? Can you tell me what is this angle? The total angle is 180 degree because this is the complete opposite. And this angle is 160 degree. So what is going to be this angle? This angle is going to be 20 degree. So can I write this IL current as 10 angle 20 degree? Yes or no? Can I write this? Perfect, Shubhajit. Are you getting this? If you can write this, now put the values here. What is going to be the load terminal voltage? It is going to be 100 angle 60 degree. What is going to be IL? IL you have just found 10 angle 20 degree. So this is 10 angle 20 degree, but you have to take the complex conjugate. If you simplify this, it will become 1000 angle 60 minus 20, it will become 40 degree. Just find the values of P and Q. Just find the values of P and Q. I think both P and Q are going to be positive. And for the load, if you are getting P and Q positive, as per the sign convention, it means the load is absorbing both the real and the reactive power. So what is going to be the correct answer? What is the nature of power absorbed by the load? Load absorbs both real and reactive power. Is it clear for everybody? Just tell me in the comment section. Are you able to follow this? Yes, everyone. I hope it is 100% clear. Any doubt, you can ask me n number of times. Let us see the next question. The next question talks about the per unit system. Every year on year, almost every year you are getting 1 or 2 questions from per unit system. So let me discuss this question. This is one of the most classical questions from per unit system, using the discontinuity of the transformer. Let us see what he is saying. He is saying there is a 10 kVA 400/200 volts transformer which needs to be approximately represented by a 4 ohm reactance referred to the low voltage side. What is the low voltage side? 200 volts. He is saying, considering the rated values as the base quantities, what is the transformer equivalent impedance as a per unit quantity? So everybody just tell me. Yes, Shubhajit, perfectly correct. So you are getting both P and Q as positive values. That is why it is going to be both real and reactive powers are going to be absorbed by the load. Now this question, I will just give you a simple understanding, which is the basic of discontinuity of transformer when you deal it with the help of per unit system. See what is happening. Suppose this is your transformer. Suppose here the voltage is V1, current is I1, voltage is V2, the current is I2. Yes or no? A 2-winding simple transformer. Now suppose the number of turns in the primary winding is N1, the number of turns in the secondary winding is N2. Suppose the total impedance of the primary side is Z1 and the total impedance of secondary side is Z2. This is the case. Now suppose I want to know how I can find the per unit impedance of the transformer, either refer to the primary side or the secondary side. Now what is the basic idea? What is the basic idea of writing the per unit impedance? You have to write the actual value of the impedance divided by the base impedance. Yes or no? Yes or no? So if I have to find the per unit value of the impedance refer to the primary side or the secondary side, then how I can write it? I will be writing Z1 per unit, or better write it Z01 per unit is equal to actual value of Z01. What is Z01? Z01 is the total impedance referred to the primary side. When you refer the secondary side to the primary side, then the total effective impedance we are writing as Z01, and this is the actual one. And this is going to be the base impedance. And base impedance of which side? At the primary side. Similarly, you can write Z02 as Z02, per unit, as Z02 divided by ZB2. What is Z02? Z02 is the total impedance referred to the secondary side. And what is ZB2? ZB2 is the base impedance at the secondary side. Now see, if I have to write the base impedance at the primary side, it is going to be what? Suppose I am taking the V1, I1 and V2, I2 as the rated values of voltage and current as the base values. In per unit system, out of these values, out of these four values, which is power, okay, power, voltage, current and impedance, out of these four values, any two values base you can choose, and rest of the two quantities base is automatically going to be fixed. It is not hard and fast that all the time you have to choose the base for the power or the voltage. So here I am choosing the base of voltage and current. So if I have to write the base impedance here, what is going to be the base impedance here? It is simply going to be V1B upon I1B. Yes or no? Tell me in the comment section. Shravan Kumar is saying, what is the role of resistance in the secondary winding in the transformer? R reduces? No, my friend Shravan, please try to understand. You must be having some confusion in the equivalent circuit of the transformer. Please try to understand. Please try to understand. Whether it is primary side or the secondary side, resistance only represent the modeling of I square R, or the copper losses in the primary or the secondary winding. That's it, nothing else. Are you getting this? We are using the equivalent circuit to model the transformer. Don't get confused. Similarly, at the secondary side, if you have to write the base, it is going to be V2B and I2B. Yes or no? Now suppose I want to write Z01. What is going to be Z01? Can you tell me the total impedance referred to the primary side? It is going to be what? Z01. I am going to give you a trick. If you are referring to the primary side, what is the trick? Please try to understand. If you are referring to the primary side, it means the primary side is as it is. So primary side impedance I am writing simply like this. What you are referring? You are referring the secondary side to the primary side. So what you are referring, that you have to divide by that side number of turns, and to where you are going you have to write in the numerator and do the square. Similarly, you can write Z02, this is going to be Z2 plus what you are referring, primary impedance to the secondary side. So it is Z1 multiplied by from where you are referring, primary side, to where you are referring, secondary side, do the square. Is it clear for everybody? Just tell me in the comment section. Are you able to follow this? Just 2 more minutes and this concept is going to be 100% clear for you for the rest of your life. Now suppose I want to know what is Z2B upon Z1B. What is Z2B? Can you tell me? Z2B is going to be V2B upon I2B. What is going to be Z1B? It is going to be V1B upon I1B. So you can write it as V2B upon V1B, and this is going to be I1B upon I2B. How you can write V2B? How you can write V2B? Please try to understand. See, you can write V2 upon V1 as N2 upon N1. Suppose I write this as K. K is the transformation ratio, N2 upon N1. So how I can write V2 or V2B? V2B I can write as K times V1. Similarly, if you see, you can write I1 upon I2 as N2 upon N1, or you can write I2B as I1B upon K. Just put these values here. So this V2B, this you can write as K, and I1B upon I2B, this also you can write as K. Yes or no? These equations, can I write this? Yes or no? So this is going to be K square. It means one thing you can write, that the base impedance for the secondary side is K square times the base impedance at the primary side. Now let us see the total effective impedance referred to the primary or the secondary side. Now please try to see here what is happening. If I have to write Z01, this is, I have just found as, sorry, I have written it here. This is going to be Z1 plus, this is going to be what? This is going to be Z2 upon K square, and this Z02 is going to be what? This is going to be Z2 plus K square Z1. So if you take K square common, this is going to be Z1 plus 1 upon K square Z2. Yes or no? Now what is this value? Z1 plus Z2 square, sorry, Z2 upon K square, this is nothing but Z01. So from here you can write one more important expression, that Z02 is going to be K square Z01. Now let us try to write finally the per unit values. So Z01 per unit is going to be Z01 divided by Z1B. Now what is Z02 per unit? This is going to be Z02 divided by Z2B. How you can write Z02? As K square Z01. And what is Z2B? It is K square Z1B. Now K square is going to be cancelled and you will be getting Z01 per unit. Now that is the classical statement, that in per unit system, the per unit value of the total effective impedance, either you refer it to the primary side or the secondary side, this is going to be same. You don't need to bother about the primary or the secondary side once you have the total effective impedance per unit value at the primary or the secondary side. This explanation is clear for everyone? Just tell me in the comment section. Everybody just tell me in the comment section, are you able to follow this? Now if you have this much clarity, now this question is going to be very easy for you. Let us see how. Now he is talking about the per unit value of the transformer. Now because he has given you the actual impedance, total effective impedance referred to the low voltage side, so we will try to find it from the low voltage side. So if you have to find Z02 per unit, it is going to be what? Z02 actual value divided by Z2B. Now what is Z02? It is given 4 ohms. What is Z2B? Can you write the base impedance for the secondary side if power and voltage is given? Yes. Z2B you can write as voltage square, that is 200 into 200 divided by power, that is 10 kVA. If you solve this again you will get as 4 ohms. So it is 4 by 4. Answer is 1 per unit. A is the correct option. Yes, Shubhajit, you are right. Everybody just tell me in the comment section, are you able to follow this? Let us see the next question. The next question talks about another fundamental concept, that is the concept of GMR, geometrical mean radius. Okay, I hope you are comfortable with the geometrical mean radius concept, but let me just give you some idea. Geometrical mean radius. In the most simple terms, you can define it is the distance. It is the distance over which internal flux is present. Internal flux is present. The basic idea of geometrical mean distance or geometrical mean radius is in terms of the distance. So this is the most simple way of defining GMR. GMD also you can define in the same way, but in case of GMD it is going to be the distance over which the mutual flux is present. Are you getting this? Now you must be knowing that when you talk about the GMD, you talk about the intergroup or interface distance. Suppose it is a single phase two wire system A and B. So when you talk about GMD, you are talking about the distance between the two groups of conductors A and B. When you talk about the three-phase system, then what is GMD? GMD is the interface distance between A and B, B and C, C and A. But when you talk about GMR, GMR means you can say it is the effective radius, you can say effective radius of the conductor, if you take into account the effect of internal flux. Now, you must be knowing how we are finding the GMR in this case. See, generally what is happening, if you have to write the GMR, how we will write the GMR? We will write GMR of the system, because it is a stranded conductor. This is a stranded conductor. This is a stranded conductor. Small strands are used. What we will do, we will find the GMR for 1, 2, 3 and 4, and we will take the effective geometric mean. This is what we are doing. But in this particular case, what is happening? It is the ACSR conductor. In case of ACSR conductor, some of the core strands we are using, we are replacing the aluminum strands with the steel strands in order to increase the mechanical strength. But what is happening? These steel strands, no current is flowing. When the current is not flowing, you cannot take into consideration the strands in which the strands which are of steel. So in case of ACSR conductor, you have to understand that when you find the GMR, you have to ignore the strands which are made of steel or in which current is not present. So we have to only focus on 1, 2 and 3. So if you see, it is going to be GMR for 1, GMR for 2 and GMR for 3, and this is going to be 1 by 3. Now by the nature of symmetry, the diagram may be somewhere here and there, but by the nature of symmetry you can understand that this is going to be an equilateral triangle. What is this distance? Can you tell me? What is this distance? If this is going to be diameter d and this is going to be d by 2 and d by 2, so this is going to be 2d. If d is the diameter, yes or no? Or if you can write in terms of the radius, then what you can write it? This is going to be r, this is going to be r, this is going to be 2r, so total it is going to be 4r. Yes or no? So what we will see whether it is strand 1, strand 2 or strand 3, they are having the symmetry. So whether you find GMR 1 or GMR 2 or GMR 3, you will be getting the same value. So by the nature of symmetry, you can say because GMR 1 is equal to GMR 2 or it is equal to GMR 3, you can simply write GMR system is equal to GMR 1, 2 or 3, whatever you want to write. Now what is GMR 1? How we write GMR? For this strand 1, if we have to write the GMR, how we'll write? First we'll write the effective radius for strand 1. So that is going to be 0.7788 r. Now what is the distance between strand 1 and strand 2? This is going to be how much? 4r. And what is the distance between strand 1 and strand 3? That is also going to be 4r. So this is going to be 4r. This is going to be 4r and this is also going to be 4r. How many total distances? 1, 2, 3. What is the power? 1 by 3. Just solve it and you will be getting the GMR. Everybody just tell me in the comment section, are you able to follow this? Is it clear? Are you getting it? Mr. Aditya Anil Kumar is saying, sir, it won't be 4r. See, it won't be 4r. See, this distance is going to be 4r, yes or no? This is r, and this is 2r, so total is 4r. The diagram is a little bit here and there, I told you, but it is going to be equilateral triangle. The figure is something like this. If any other diagram is given, then accordingly you have to find the value. I know you must be saying, sir, suppose this is not equilateral triangle and this is 4r and this is suppose some value, you have to find it, see the angle bisector like that. So if you want, you can do like that also. Adit Kumar is saying it will be 2 root 2r. Yeah, that is what I'm saying. See, if you do it like this, if you say this is going to be 2r and this also you are saying 2r, so from there, yes, you can say as per the diagram, as per the diagram this is going to be 2 root 2r, correct, as per the diagram given. But what I wanted was to have the distance in such a way that it is equal. Shubhajit, they can give you conceptual questions also. They can give you some conceptual questions also. So you must have the concept. Okay, they may suppose instead of giving you a final value, they can give you some value out of this. So accordingly you can do it. Now it is okay, Mr. Adit. I hope it is okay. So let us see the next question. The next question talks about the direction of real and reactive power flow. I hope you must be comfortable with the direction of real and reactive power flow. So very easily you can solve this question directly. Let us try to increase the speed, because I see some of the students, they may be finding the speed little slow. But if you have any doubt anywhere, you can ask me again and again. I will be trying to answer your question. He is asking the direction of real power. How we find the direction of real power? The first thing we have to check is x by r line greater than x by r load. If this condition is fulfilled, then we say that the real power flows from the leading voltage terminal to the lagging voltage terminal. If you see, it is simply a lossless line. R value is not given, or it is assumed to be 0. It means definitely the x by r ratio for the line is going to be very, very high in comparison to the load. So you can directly assume from the leading voltage terminal to the lagging voltage terminal, the real power flow is going to be there. So for real power, you can be 100% sure that it is going to flow from node 1 to node 2, or bus number 1 to bus number 2. Is it clear? So statement 1 is going to be correct. Statement 4 is going to be wrong. Now when you talk about the direction of reactive power flow, you should double check it. For example, in the first case, I will assume that the reactive power is flowing from 1 to 2. Okay, this was for real power. Now suppose we talk about the reactive power. You are assuming that the reactive power is flowing from bus number 1 to bus number 2. This is what you have assumed. In that case, what should be the condition? The condition should be that mod V1 cos del must be greater than mod V2. What is mod V1? Mod V1 is 1. It is given as 1 angle 30 degree. So mod V1 is 1, mod V2 is 1, and del angle is 30 degree. So this is going to be 1 cos 30 degree. It is greater than 1, which is not possible. Cos 30 can't be more than 1. We have assumed that the reactive power is flowing from 1 to 2, but it is wrong. So we are saying no, real power is flowing from 2 to 1. But I told you that in case of reactive power, you have to be double confirmed. So what we will do? Now we will assume that the reactive power is flowing from 2 to 1. 2 to 1. So when you are writing 2 to 1, what is the condition you have to put? It should be V2 cos of minus del. You understand? Why minus del? Must be greater than mod V1. What is mod? V2 is 1. Cos minus 30 is same as cos 30, and it must be greater than V1 magnitude, that is 1, and this is not possible because cos minus theta is again cos theta. So you cannot say that cos 30 is going to be greater than 1. So this proposition is also wrong. So when we are assuming that the reactive power is flowing from 2 to 1, Again it is coming as wrong, and we are getting that the reactive power is flowing from 1 to 2. Now you will be confused what is happening. Actually what is happening here, if this is your bus number 1, if this is your bus number 1 and this is your bus number 2, what is happening here, actually 1 to 2 reactive power is flowing like this, and 2 to 1 reactive power is again flowing like this. It means the reactive power is flowing from 1 to 2 also and 2 to 1 also. You will say, sir, where it is going? It is actually being consumed by the transmission line itself. You must be knowing. You are comfortable with this or not? Yes or no? Your transmission line is also going to absorb the reactive power, na? So in this case, both of these two statements are going to be correct. The reactive power is flowing from 1 to 2, the reactive power is flowing from 2 to 1. What is the correct answer? The correct answer is A option. Is it clear for everybody? Just tell me in the comment section. Is it clear? If you have any doubt, you can ask me. See the next question. See the next question. The next question talks about a short transmission line. The series impedance is given in per unit. He is saying which of the following voltage regulation value is possible to get at the leading power factor at the full load condition. Now please try to understand. I will just show you the graph also, the characteristic graph also, but understand that for the leading power factor for the short transmission line, there is a general case. The voltage regulation is always less than R per unit. What is R? R is the transmission line R. R is the transmission line R. Similarly, for the lagging power factor, the voltage regulation is always more than R per unit. So if you know this, then directly you can answer. What is R per unit? R per unit is 0.08. So can I write it in percentage as 8%? What are the possible value of voltage regulation? It must be less than 8%. So this can't be, this can't be, this can't be. What is the correct answer? D. If you are okay with this concept, I will just go forward. Are you getting this? See, don't worry about the calculators, because the person who is going to set your examination paper, he will not try to check your calculation speed. He will just check your knowledge and your time management. If you are giving more than 1.5 minutes, in general 1.5 minutes in one question, it means you are losing the examination. Better leave it there and go for the next question. This is the common sense. This is the common sense. Everybody is okay with this concept? Can I just proceed? Can I just proceed? See the next question. See, the next question, lot of data is given, but if you have the common sense, very easily you can solve this question. I will give you a basic idea about the Ferranti effect, and this concept is going to help you in many ways. See, basically what is happening here, he is giving you some data, 200 kilometer medium transmission line, this, that, RLCs are given in terms of per unit distance traveled over the line. He is saying assume the receiving end capacitor model. What is receiving end capacitor model? Let us see. The receiving end capacitor model is something like this. This is the lumped parameter model, and we use it for the medium transmission line. This is your sending end voltage, sending end current. This is your receiving end voltage. This is your receiving end current, and this is the charging current. Are you getting this? RLC. Yes, everyone. Are you getting this? Now please try to understand what is happening here. Let us try to understand. Ferranti effect. Actually, he is talking about a parameter magnitude. Directly, he is not talking about Ferranti effect, but actually this concept is based on Ferranti effect. So let me just first tell you some basic idea about Ferranti effect, which is going to be very important for you. Ferranti effect simply tells you that at no load or lightly loaded condition, lightly loaded condition, what is happening? Lightly loaded condition, what is happening? The magnitude of the receiving end voltage becomes more than the magnitude of the sending end voltage, and this phenomena we are calling as Ferranti effect. Now my friend, please try to understand why this effect is happening. There are two conditions. I will tell you what are those two conditions, but before that let me just draw the phasor diagram. Suppose here you are saying IR is 0. If IR is 0, so whatever current is present here, this is going to be only the charging current. Yes or no? Yes or no? So if this is the receiving end voltage, okay, this is the receiving end voltage, the charging current is the current which is present in the line, so this is going to be charging current. Now charging current, because it is passing through the capacitor, so this is going to be a leading current. This is going to be leading current, so the current is leading the voltage. Now this leading current which is passing through this R and L, it is going to have two types of voltage drops. One is the resistive drop and one is the inductive drop. So what is happening? The resistive drop is going to be something like this in the direction of the current. So this is going to be IC into R. But the resistive drop is going to have a phase difference of 90 degrees. So this is going to be somewhere like this. This is going to be IC j omega L. Then what is going to be the sending end voltage? This is going to be something like this. Now very easily from the phasor diagram you can understand that the receiving end voltage is going to be, magnitude is going to be more than the sending end voltage. If you want to make this diagram more clear, then you can understand. Let us try to simplify this circuit and we say, suppose this R is also 0. If this R is also 0, you can draw this diagram again. Suppose this is the receiving end voltage and suppose this is the charging current. If R is 0, only the inductive drop is present. Now this inductive drop is going to be something like this. This is going to be IC j omega L. Now what is going to be the sending end voltage? This is going to be something like this. Now from this diagram you can understand that the receiving end voltage magnitude is going to be more than the sending end voltage magnitude. Now why this difference is occurring? This difference is occurring because of this component. Now this component has two propositions. Number one, what is IC? The line current. So what is the first condition for Ferranti effect? Line current must be dominantly capacitive in nature. This is the first one. What is the second condition? This dominantly capacitive current must be passing through the inductive element of the line. Must be passing through inductive element of the line. Yes or no? Are you able to follow these two conditions or not? If this is happening, you can say Vs is less than Vr. Now, what if Ferranti effect is present? Please try to understand. Let me just write it in terms of the equation. Vs is equal to AVR plus BIR. Because you are talking about Ferranti effect, so you are talking about no load condition. It is also given here in the, okay, not there, no problem. So you can say that IR is 0. When IR is 0, you are writing Vs and this is going to be A and this is VR no load. You can write Vs upon VR no load is equal to A, or you can simply write magnitude A is magnitude Vs upon magnitude VR no load. Now as per the Ferranti effect, you can very easily understand this value is going to be less than 0 because the sending end voltage is less than the receiving end voltage. So very easily you can write mod A less than 1. I was just trying to explain you, otherwise there is no need to go through up to this much length. Directly you observe this question and you understand. If IR 0, what is the line current? The line current is dominantly capacitive, first condition fulfilled. This dominantly capacitive current is passing through the inductive element of the line, second condition also fulfilled. When both the conditions fulfilled, it means there is going to be there may be some, I think, some technical electricity issue.